So Monday and Tuesday, or not Monday and Tuesday, Tuesday and Wednesday, we talked about finding limits of functions using tables and graphs. And that's great, but it's not always convenient to have a table and a graph. So today and tomorrow, we're going to look at some algebra techniques for finding limits. And you'll find today anyway, everything is pretty straightforward, pretty simple. So a couple formulas that we can use to develop other formulas. The limit of a constant. If we have a function, f of x, that is just equal to some value, so it's a horizontal line, then the limit as x approaches any number of that function, f of x equals b, is just b. Your limit will, in this case, always just be that constant. If we take the limit of the identity function, which is f of x equals x, then as x approaches c, our limit for x also is c. So if we're equal to a constant, that constant is our limit. If we're equal to x, whatever value we're approaching is our limit. So we could take a look at some examples. The limit as x approaches 3 of 5. That's like our first example, the limit of a constant. Doesn't matter what x is, our limit is always going to be that constant. The limit as x approaches 3 of x now is the time where we get that value as our limit. So hopefully that makes sense. If you think about it graphically, this case would be, we have our line. Whoa. Let's try that again. We have a line at x equals 5. Wow. And this one would just be our line y equals x. And so on this one, if we're starting at 3, or as we approach 3, because y equals x, that's our y value as well. All right, 3 other limits that we're going to talk about today. The limit of a sum. If I take the limit as x approaches a value c of f of x plus g of x, what I can do is break that sum apart and find the limit as x approaches c for f of x and the limit as x approaches c for g of x, and add the two together. I can do the same thing with subtraction. Find the limit of the first function, find the limit of the second function, and then subtract the two. In fact, I can also do that for a product. Take the limit of the first factor times the limit of the second factor to get the limit of the product. All right, so we're going to do a couple of examples. And I'm going to be very thorough through these examples. I don't expect that you're going to do these the same way. My guess is you would take a look at this and you'd plug -3 in for x and get your answer, which is great. The reason we can do that is we have the property about sums, which say the limit of that sum is the limit of the first plus the limit of the second term, which means the limit of the first term, that's our friend, the identity function. So we're going to get what x is approaching, -3. The second one is the limit of a constant. So we just get that constant to get a value of 1. So I don't expect you to break them apart like that. You don't have to. You could just plug the -3 in and say the limit as x approaches -3 of x plus 4 is -3 plus 4, 1. And if we use that again for the second one for subtraction, again, I'll do the long way. That's the limit as x approaches 4 of 6 minus the limit as x approaches 4 of x. So we get 6 minus 4 is -2. And if we apply that to our product rule, the limit as x approaches -5 of -4 times the limit as x approaches -5 of x. So again, our limit of -4, doesn't matter what x approaches, we get -4. Limit of x as x approaches -5, so I get the value that I'm approaching to give me a positive 20. So again, you could also find that just by taking -5 and plugging it in. There will be times when we can't do that. Today is not one of those times. So assignment page 883, numbers 7 through 16.